Question for this subject, construction materials and testing. And we are already on our last week now for our discussion, and this will be the second lesson for this week, no, 2 out of 3. So for this lesson, we are going to talk about the determination of tensile strength of reinforcing steel bar. So steel reinforcing bar or rebar is embedded in concrete to improve the overall strength of the concrete that surrounds it. Material product standards exist to help ensure that a rebar produced throughout the world exhibits the same physical, chemical, and mechanical properties regardless of the source. Proper mechanical testing is then necessary for determining if the rebar meets its published specification, ensuring the quality of the product. So mechanical testing requirements for a rebar can vary, but typically fall into the following basic test categories. We have the tensile strength determination or the tensile test. Now we have the bend test. We also have the compression test and the fatigue test. Other related product testing, such as sleep testing of mechanical splices or couplers, may also be required. This document will focus primarily on the very common, yet sometimes challenging, tensile test. At a global level, technical committees governed by the International Organization for Standardization or ISO develop product and testing standards for reinforcement bar products. In addition to specifying properties such as the minimum upper yield strength and elongation values for rib steel products, ISO products standard such as ISO 6935-2 also specify how the tensile properties are to be measured. Unique testing requirements for the product are included directly in the standard, and additional reference is made to ISO 15630-1, which focuses specifically on test methods for similar products. ISO 15630-1 provides further references to more general metals tensile testing standard, and ISO 6892-1 where applicable. So here are the codes or numbers no, with respect to the standard institution, no, with respect also to the tensile strength and tensile determination or tensile strength determination or tensile testing and standards. No. For the rubber product standard no, under ISO, it has a number or a code of 6935-2, and for ASTM, ang iyang code, yung number is A615. And for rebar testing standard, ang iyang number or code sa ISO is 15630-1, and pag abot sa ASTM, yung equivalent is A370. And for the metal tensile test standard, no, sa under ISO, it has a code of 6892-1, and yung equivalent sa ASTM is E8. So basically, we have two standards no, that governs the tensile or even test of rebar products no, under ISO and ASTM. So regardless of the governing body, the information provided in most global and local standards is quite detailed and intended to help the user understand the following basic testing requirements. Okay? So muna siya ang coverage kay bali na regardless of which governing body or standard institution ang nag-provide sa standard specification no mo ni siya ang general coverage of those standards no. We have the equipment required no, and also the associated terminologies and symbols, also the specimen preparation, testing procedures or methods, and calculations or results to be determined. Even though standards provide these thorough details, some aspects may still be left to the user's interpretation, which can often lead to variations in how the testing is performed. Additionally, if a lab is testing product to a variety of global or local standards, it can be challenging to fully understand and capture the subtle differences in terminology and methodologies found in different standards. So among those standard specification and standard test methods now that I have mentioned earlier under ISO and ASTM, we only talk ang isa lang, no? We just pick one of those and then we discuss. Okay, that is the ASTM A370 or the standard test methods and definitions for mechanical testing of steel products. Okay. For the scope of this test, or this standard test methods, no, or ASTM A370. These test methods cover procedure and definition for the mechanical testing of steels, stainless, and related alloys. The various mechanical tests herein described are used to determine properties required in the product specification. The following mechanical tests are described. So, muna siyang upat ka test ng cover sa kaning standard test methods now for mechanical testing of steel products or ASTM A370. One of that is the tension test. Second, the bend test. Third is the hardness test, which can either be Brinell, Rockwell, and portable hardness test na, and we also have impact or the Charpy impact testing. No? And for the sake of this lecture note, we are only going to talk about the tension test. Okay, so the description, the tension test related to the mechanical testing of steel products subjects a machined or full suction specimen of the material under examination to a measured load sufficient to cause rupture. For the testing apparatus, for the first, we are going to need the loading systems or present na siya dito sa machine or apparatus nga that can carry out tension tests. So, nadiha ang loading system. So, there are two general types of loading systems, the mechanical and the hydraulic loading system. These differ chiefly in the variability of the rate of load of application. The older screw power machines are limited to a small number of fixed free running crosshead speeds. Some modern screw power machines and all hydraulic machines permit stepless variation throughout the range of speeds. The tension testing machine shall be maintained in good operating condition, used only in the proper loading range, and calibrated periodically in accordance with the latest revision. Second is the loading. No? It is the function of the gripping or holding device of the testing machine to transmit the load from the heads of the machine to the specimen under test. The essential requirement is that the load shall be transmitted axially. This implies that the centers of the action of the grips shall be in alignment insofar as practicable with the axis of the specimen at the beginning and during the test, and that bending or twisting be held to a minimum. For specimens with reduced section, gripping of the specimen shall be restricted to the grip section. In case of certain sections tested in full size, non-axial loading is unavoidable and in such cases shall be permissible. Second is for the speed of testing. The speed of testing shall not be greater than that at which load and strain readings can be made accurately. In production testing, speed of testing is commonly expressed in, first, in terms of free running crosshead speed, that includes the rate of movement of the crosshead of the testing machine when not under load. Second, it can also be in terms of rate of separation of the two heads of the testing machine under load. And it could also be in terms of rate of stressing the specimen or in terms of rate of straining the specimen. The following limitations on the speed of testing are recommended as adequate for most steel products. For the test specimen parameters, so first we do the selection, or for the selection, test coupon shall be selected in accordance with the applicable product specification. For the size and tolerances, test specimens shall be one of the full cross-section of the material. The selection of size and type of specimen is prescribed by the applicable product specification. Full cross-section specimens shall be tested in 8-inch or 200 mm gauge length unless otherwise specified in the product specification. Now for the procurement of test specimen, specimens shall be extracted by any convenient method taking care to remove all distorted, cold-worked, or heat-affected areas from the edges of the section used in evaluating the material. Specimens usually have a reduced cross-section at mid-length to ensure uniform distribution of the stress over the cross-section and localize the zone of fracture. Next is the aging of test specimen. Unless otherwise specified, it shall be permissible to age tension test specimen. The time temperature cycle employed must be such that the effects of previous processing will not be materially changed. It may be accomplished by aging at room temperature 24 to 48 hours or in a shorter time at moderately elevated temperatures by boiling in water, heating in oil, or in an oven. For the measurement of dimensions of test specimen, standard round tension test to determine the cross-sectional area, the diameter shall be measured at the center of the gauge length to the nearest 0.001 inch or 0.025 millimeters. Now for the testing procedure, first you measure and record the specimen dimensions necessary to determine the cross-sectional area at its smallest point. The original cross-sectional area is used for all engineering stress calculations. Second, you mark the gauge length with a center punch, scribe marks, or draw with ink. The distance, the distance between the gauge marks after the specimen is broken is used to determine the percent elongation at break. Third, zero the testing machine without the specimen inserted in the grips. Then install the specimen in the grips and attach a Class B1 eggshell extensometer at the specimen. Please note that the extensometer needs to be removed prior to specimen failure. ADMET software stops test and prompts the removal of the extensometer once the total strain data has been satisfactorily obtained. Fourth, you start loading the sample. The speed of testing is generally specified in one of three manners. First, the rate of movement of the crosshead of the testing machine when not under load, or the rate of stressing of the specimen, or the rate of separation of the crossheads under load. Any convenient speed of testing may be used up to 1/2 the specified yield point and down to 1/10 the specified maximum rates for determining yield strength and tensile strength. Fifth, run the test until specimen failure or fracture. Remove the broken sample from the machine and fit the fracture ends together. And then you measure the distance between the gauge marks to the nearest 0.05 millimeters. Okay, so that ends the proper procedure now of the test. Now we go to determination of tensile properties. First under that is the yield point. Yield point is the first stress in a material, less than the maximum obtainable stress, at which an increase in strain occurs without an increase in stress. Yield point is intended for application only for materials that exhibit the unique characteristics of showing an increase in strain without an increase in stress. The stress-strain diagram is characterized by a sharp knee or discontinuity. Second is yield strength. Yield strength is the stress at which a material exhibits a specified limiting deviation from the proportionality of stress to strain. The deviation is expressed in terms of strain, percent offset, total extension under load, and so forth. Next is the tensile strength. You calculate the tensile strength by dividing the maximum load the specimen sustains under a tension test by the original cross-section area of the specimen. If the upper yield strength is the maximum stress recorded, and if the stress strain curve resembles that of test method E8 or E8M, the maximum stress after discontinuous yielding shall be reported as a tensile strength unless otherwise stated by the purchaser. Now, fit the ends of the fractured specimen together carefully and measure the distance between the gauge marks to the nearest 0.01 or equivalent inch or equivalent centimeter 0.25 for gauge lengths of 2 inches and under, and to the nearest 0.5% of the gauge length for gauge lengths over 2 inches. A percentage scale reading of 0.5% of the gauge length may be used. The elongation is the increase in length of the gauge length, expressed as percentage of the original gauge length. In recording elongation values, give both the percentage increase and the original gauge length. Now for the reduction of area, fit the ends of the fractured specimen together and measure the mean diameter or the width and thickness of the smallest cross-section to the same accuracy as the original dimensions. The difference between the area thus found and the area of the original cross-section expressed as percentage of the original area is the reduction area. Okay, so here are some videos no from YouTube wherein gipakita no ang procedure sa tensile strength test on rebar. So if you want, you can watch this na duha ni siya ka video, and then they all cover the tensile strength determination or test on rebars. Okay, that will be all, and thank you so much.